Hello students, in this video we'll see several properties of the adjugative matrix. Let's be given an n by n matrix A and consider Aij, our standard thing, the matrix A with row I and column J removed. Then adjugative A is the matrix that looks like -1 to the I plus j times the determinant of Aij. That's just the cofactor, the ij cofactor, and we take the transpose of this matrix over here, right? In previous videos, we showed the following result. Recall that A times the adjugative A is the determinant of A times the identity matrix, right? And so what are some immediate consequences of this definition over here, right? So a couple consequences we have are the following. So here's the first consequence, a little proposition. So proposition is the trivial one. So this immediately implies that if determinant of A is not equal to 0, right? In other words, if A is invertible, right? Then that says the adjugative of A divided by the determinant of A is the inverse of A. And this implies that A inverse is the adjugate of A over the determinant of A. It gives me a way of computing the inverse from the adjugate, right? Let's do some other properties of adjugate. So for example, here's a proposition. What would the adjugate, let's do the symmetry first, actually. So let's consider what's the adjugate of AB, right? I claim the adjugate of AB is the adjugate of B times the adjugate of A. Let's figure out what that be. So what can I say? Well, let's figure this out. So I can consider A times B times the adjugate of AB. That's going to be the determinant of AB times the identity, which is the determinant of A times the determinant of B, right? Determinant of A times the determinant of B times the identity, right? And so that gives us a hint, right? So let's assume that A and B are invertible. If A and B are invertible, then what would this have to be? Then the adjugate of AB will have to be the adjugate of B times the adjugate of A, right? Because if A and B are invertible, then the adjugate of A is equal to A inverse times the determinant of A, and that gives us the exact result over here. So this is true for invertible matrices A and B, right? And then by continuity of the eigenvalues, it follows for all matrices A and B. So we get this result over here, right? And so in other words, what we can do is we can sort of use this idea over here to construct sort of a formal proof of this fact, right? So let's do it like that. So the adjugate of AB, proof, the adjugate of AB will be equal to what? Will be equal to A inverse times the determinant of AB. So this is going to be AB inverse times the determinant of AB, assuming they're invertible, of course, right? And then this, of course, is just going to be B inverse, A inverse times the determinant of A, determinant of B by properties of determinants, right? And of course, this thing over here is going to give me the adjugate of A, and that's going to give me the adjugate of B, but B comes first over here. So I can filter this determinant of B over here. So that's the adjugate of B times the adjugate of A, and we get this result over here. That's great. So in other words, the adjugate has this reversing property. And now, what if we do two adjugates in a row, right? So here's the next proposition. So let's figure out, so let's now consider the adjugate of A. And again, we're going to assume that A inverse exists, and then we're going to use the continuity, the density of the matrix whose eigenvalues are not 0 exists, right? Then what will this give us over here? Then this is going to give us the adjugate of A is going to be equal to the adjugate of what? Now the adjugate, when A inverse exists, is going to be the determinant of A times what? Times A inverse. And now we need a little lemma because that's a real number over here. That's just a real number. And so now the question becomes is how does adjugate handle scaling, right? And so here's a lemma for this. And so our lemma is that the adjugate of lambda A is lambda to the n minus 1, the adjugate of A. So I can pull out n minus 1. So how did I prove this lemma over here? So the proof goes as follows. right? So like, assuming invertibility again, the adjugate of lambda A is going to be the determinants of A times this inverse of this thing over here. So it's going to be the determinant of lambda A times the inverse of lambda A. Okay? And so this, of course, is going to be equal to what? It's going to be lambda to the n determinant of A times lambda to the negative 1 A inverse, right, by properties of inverses. And so this becomes lambda to the n minus 1 determinant of A times A inverse. And that's exactly just what? That's exactly just lambda to the n minus 1, the adjugate of A. So that gives us that lemma over here. And so now what I'm going to do is I'm going to pull out that many copies of the determinant of A, right? So in other words, by our lemma over here, this becomes determinant of A to the power n minus 1. And then what? And I can pull that out, then I have the adjugate of A inverse, right? Then the adjugate of A inverse. So I get determinant of A to the n minus 1. And what's the adjugate of A inverse? It's the determinant of A inverse. So I have the determinant of A inverse times the inverse of A inverse, inverse. Of course, that's just equal to A, and that's the determinant of A to the n minus 2, right? So what's the adjugate of the adjugate? This tells us that the adjugate of the adjugate is equal to what? Is equal to the determinant of A to the n minus 2, and then times A itself, right? So there's this involutive property up to this factor of the determinant, right? And so, of course, we can therefore conclude from this that we can take this result over here and actually conclude the following fact, that the determinant of the adjugate is the determinant of A to the power n minus 1, right? So that gives us this result for free, basically, because you can just take the adjugate of this result and get that result for free. So there are two very important properties of this adjugate, namely of this reversing of the order of the adjugate of a product, and then the adjugate of an adjugate restores the original matrix up to a factor of the determinant of the original matrix to the power n minus 2. Thank you very much.